Let us have a discussion about sequences and series. A sequence is defined as an ordered list of objects containing elements. The number of elements is defined as the length of the sequence. A length of the sequence can be finite or infinite. We will discuss two types of progressions today, or sequences. We will discuss the arithmetic progression and we will discuss the geometric progression. An arithmetic progression is defined as a sequence of numbers so that the difference between consecutive terms is constant. For example, if I have a sequence or progression of 1, 3, 5, 7 and so forth, I can easily see that the difference between term 1 and term 2 is 2, the difference between term 3 and 5 is 2, and this continues on. So we can say this is an arithmetic progression with a common difference of 2. Now, let the initial term of an arithmetic progression be defined as A1. That is our initial term, and let the common difference be defined as D. Right, so we say the initial value of the arithmetic progression is A1, and the common difference between consecutive terms within the progression we define as D. Then we can say the nth term. Then the nth term is An, which is the nth term, is equal to A1, which is the first term, plus n minus 1 times the common difference. Now this is a very easy and powerful formula to calculate the nth term of an arithmetic progression, and we can see that it is derived purely from logic within our definition of an arithmetic progression. What we mean by that is we obviously know that the first term will always be A1, so if n is equal to 1, this will be 0 and the first term will be A1. The second term is A1 plus D, which conforms to the basic definition of an arithmetic progression. For example, the third term will be A1 plus 2 times the common difference, which gives us, if we look at our example, which gives us 5. And thus this formula, which is the basis of an arithmetic progression, is a fundamental formula for calculating the nth term in an arithmetic progression. Note that this common difference can be positive or negative. It does not matter. To get more comfortable with an arithmetic progression, let us do an example, which is an exam example of an arithmetic progression. Okay. Now, what the examiner has given us is the first three terms of an arithmetic progression, and they are defined as follows by the examiner. The first term is defined by 2x plus 1. The second term is defined by x minus 3, and the third term is defined by 3x minus 4. The question of the examiner now is, what is the value of x? So if we just look at this, we've been given the first three terms of the arithmetic progression as a function of x, and the first question by the examiner is, what is the value of x? Let us again start to solve this problem. Let us start with the basic formula of an arithmetic progression given by this equation here, and thus we can say from this just by simple method of applying this formula that a1 is equal to 2x plus 1 is given by 2x plus 1, and the difference d can easily be calculated by the difference between the second term and the first term. So okay, so let's do that. We then say a1, it's very easy, is then equal to 2x plus 1. That is being given to us, so it's very easy to write down. We can say the common difference is the difference between the second term and the first term, which is given by the second term is x minus 3, the first term is 2x plus 1. And we can then just simplify this equation very easily by writing this as x minus 2x will be minus x, and minus 3 minus 1 will be minus 4. So the common difference, d, which is our common difference, is given by minus x minus 4. If we just go back to what is given, the third term that the examiner gives us is 3x minus 4. So we can use that information. We know we've got an expression as a function of x of d. We've got an expression as a function of x of a1. We can just use this basic formula of an arithmetic progression to then subsequently write down the value for the third term, which we define as a3. The third term a3 is then equal to 3x minus 4, which is equal to a1, which is 2x plus 1, given by the problem statement, plus we know that if we go back to our basic formula, we know that n is 3 because we are dealing with the third term in the arithmetic progression. So that will then be 3 minus 1 multiplied by the common difference, which we calculated as minus x minus 4. Then again, it's very easy to simplify this equation. If we can then easily state that 3x minus 4, if we just collect terms on the right hand side of the equation, we see that 2x plus 1 minus 2x, 3 minus 1 is 2, multiplied by minus x is minus 2x, so the x is cancelled, and this will be then plus 1 minus 8, which gives us then minus 7. And then if we just solve for x, which is a very easy calculation to do, x will then be equal to minus 1. Thus the value, the first question of the examiner has been answered, and he said the first, in other words, he asked us what is the value of x, and we just, by simple application of an expression for the arithmetic progression, we have calculated x as minus 1. The second question of the examiner is what are the first three terms? Now this is another simple application of our basic formula for an arithmetic progression. Is, in other words, we've been given the first three terms. We've calculated x to be minus 1, so it is a simple substitution of x equal to minus 1 in all the first three terms. So then we can easily, from substituting x into these first three terms, we can simply write down the first three terms to be minus 1 is the first term, minus 4 is the second term, and minus 7 is the third term. And we can see that the common difference within this specific arithmetic progression will then be minus 3. From minus 1 to minus 4, the common difference is minus 3. From the second term to the third term is from minus 4 to minus 7, and the common term again is minus 3. Because we've been given by the examiner that we are dealing with an arithmetic progression. The third question the examiner asks in terms of this specific problem is to write down the nth term of the sequence. What is the nth term? In other words, this is just a mathematical expression as a function of n. So if we again start with the general formula for an arithmetic progression, it's given by a1 plus n minus 1 times the common difference, which we define as d. We did calculate d equal to minus x minus 4. If x is minus 1, minus times plus multiplied by minus 1 gives us a plus. 1 minus 4 gives us minus 3. We also saw this by just inspecting the answers of our arithmetic progression. So the d is minus 3. So we can now substitute for minus 3 as d. And we've also calculated on the previous slide, we've calculated the first term to be minus 1. So then we can say, okay, an is equal to minus 1 plus n is a variable, n minus 1, and we said that d is equal to minus 3, and then we can easily just simplify this equation, and we come to the equation of an is equal to 2 minus 3n, which is a very nice and powerful way for this specific arithmetic progression to calculate the value of the nth term if we know if we want to know what a specific term in the progression's value is. So if we want to calculate the third term, this is 3 times 3 is 9, minus 9 plus 2 is minus 7, and that confirms what we've calculated here.